previous classes, we have completed discussing about spanning tree protocol, right? So spanning tree protocol is to avoid layer 2 switching loops in redundancy topology by blocking a port. To block the port, STP uses selection process, like root switch selection, root port election, designated, non-designated, STP port states. Okay. And STP advantages, disadvantages. Like each port waits up to 50 seconds before data is sent on the port. So this delay can cause problems. To overcome, Cisco developed one feature called port fast, but port fast is not recommended for between the switches. Is only recommended for in-device connected. Okay. Now, say next scenario between two switches. Switch A some user connected and switch B some user connected. Like how to enable communication from switch A users to switch B users. Between A to B switch, there is one link required. I've connected one link between port number 1 to port number 1 from switch A to switch B. So there are fast Ethernet ports. Switch A ports and B ports are fast Ethernet ports. Then what about link speed? Link speed will be
100 Mbps.
100 Mbps. So now all switch A and B users can exchange the data with how much speed? They're connected with first link and data exchange with 100 Mbps. Now what if link fails between A to B? No communication. Called single point of failure. To eliminate single point of failure, backup link are required. So I'm using one backup link from port number 2 to port number 2. Even port number 2 link is also fast Ethernet, speed is what? 100 Mbps. So we call it is redundancy topology. When we have a multiple links in between the switch, then loop will form. To preventing the loops, we need to enable protocol called STP. What STP will do? It will block any one port actually. Let's say port number 2 is blocked by spanning tree protocol election process. Now data exchange happens via which link with how much speed? Now data exchange with possible with first link with 100 Mbps. Like what if first link fails? Then block port will come to forward state. Data exchange possible with how much speed? 100 Mbps only. Like what if this link is also down? Both links are failed. So based upon number of failure chances, we can connect multiple links actually. I'm connecting one more link from port number 3 to port number 3. So even port number 3 link is also how much speed? Fast Ethernet is a 100 Mbps link. Now what STP will do? So STP will block port number 3 also because STP allows only one link to preventing the loops. Even if you have a 3 links between the switch, STP allows only one link. Now users can extend the data with first link with 100 Mbps. If first link fails, what if first link fails? Out of 2 block ports, any one port will come to forward state. Second link with 100 Mbps only. This also fails. Next block port will come to forward state with 100 Mbps. So we have between switch A to switch B, 3 links are available, but we are using only one link. It's 100 Mbps only. Then how can utilize three links? How we can utilize multiple links? Because STP allowing only one link in 100 Mbps only. You want to exchange very huge data, large data exchange with 100 Mbps is not good speed now. Then we have one mechanism which we called ether channel, port channel. We are aggregating the link actually. So how this ether channel works? Ether channel is going to be combined multiple physical links into one logical link. It will combine is all multiple physical links into one logical link. It's create one logical link actually. Three links are combined. So means now data can go via first link also. Data can go via second link also. Now data can go via third link also. So now how much speed you're utilizing right now? 300 Mbps. So how much bandwidth is available? We can utilize full bandwidth. We have a 4 links 400 Mbps. We have a 5 links 500 Mbps. The purpose of aggregating, the purpose of Ether channel to utilize full bandwidth utilization. How much bandwidth is available? Full bandwidth utilized. Next point. Now data is going via not only going via one link. Data can go via first link, second link, third link. Means traffic is being load balanced. But STP will do what? Before Ether channel, it allows only one link. Then complete data has to go via first link. More load, more burden. But now traffic or load balanced. Some traffic on first link, some traffic on second link, faster communication. Load balance. So out of 3 links, if any one link fail, still we have 2 links are available. It means it provides redundancy also. So these 3 major points Ether channel can support to utilize full bandwidth, load balancing and redundancy. Okay. Ether channel combines 2 or more physical links into one logical link. The purpose of aggregating link is achieve full bandwidth, load balancing and redundancy. Generally configured between switch to switch, switch to router, switch to firewall. Ether channel can consist of up to 8 interfaces. In our example, we connected 3 links, right? But it consists of up to 8 interfaces. To create Ether channel, all port needs. This criteria has to be met to create the Ether channel. What is that? If switch A ports are, switch A 1, 2, 3 ports are Ethernet ports and switch B ports also must be Ethernet ports. Switch A ports are fiber ports, optical fiber ports. Switch B ports also should be optical fiber ports. Switch A ports are 100 Mbps, then switch B ports also should be 100 Mbps, same speed. Switch A ports are half duplex is enabled, B also should be half duplex, or full duplex, full duplex. Switch A ports are in access port, B also should be access port. Switch A ports are in trunk, then B ports also should be trunk. Switch A ports are in VLAN 1, B ports also should be in VLAN 1, same VLAN. So to create Ether channel, all port needs same physical ports, same speed, duplex, either port should be in access, either port should be in trunk. Native VLAN means local VLAN, which is VLAN 1, allowed VLANs and trunk ports. Then only you can create Ether channel action. Okay. Yeah. Anyone remember DTP? What is DTP? DTP is dynamic trunking protocol. Remember, guys?
Will be enabled in all Cisco switches by default.
Yeah. What is the purpose? What is the purpose of it? Yes, please. Dynamic trunking protocol is used to negotiate dynamic negotiations between the switches to form a trunk, automatic trunking. One side if you configure trunk, other side automatic trunk will form. Remember?
Yeah, yes.
Yeah. So modes are dynamic, desirable,
Dynamic auto.
dynamic auto. So dynamic desirable actively initiate negotiation messages to form a trunk. Dynamic auto is passively wait to receive negotiation messages to form a trunk. Agree? Similarly, ether channel also can be done in three ways actually. Ether channel can be configured in three ways. First one is static ether channel, manually and fixed. So if we configure static ether channel for 1, 2, 3 ports, then 1, 2, 3 ports we have to use only for what purpose? Ether channel purpose. That's all. We can't use that ports for any other purpose, connecting devices, any other devices, because static ether channel until we change the configuration. Or dynamic ether channel. It's automatically it'll form ether channel and we can change. Dynamic ether channel also there are two protocols based upon vendor, like A and B. Both switches are Cisco switches. Both are Cisco vendor. Then there is one protocol called PAGP, Port Aggregation Protocol, PAGP. So this PAGP is a Cisco proprietary protocol. Has a two modes, desirable and auto. So if you configure desirable, then it will actively initiate negotiation messages to form ether channel like a trunk DTP protocol. If it is auto, it's passively waiting to other side switch to ask ether channel to form action. So this is Cisco proprietary protocol. And what about for non-Cisco switches? For non-Cisco switches, there is another protocol called LACP, Link Aggregation Control Protocol. LACP has two modes, active and passive. Active mode and passive mode. Desirable is similar to active, auto is similar to passive. It's an open standard protocol. So there are three methods: static, PAGP, LACP. Okay. Let's see the configuration part. This is the configuration for PAGP and LACP. Interface, Ethernet port, numbers, channel, protocol. First we need to enable protocol, either PAGP or LACP. And channel group, like 1, 2, 3, 4, 5, 5 links or 3 links. We are combining, means you are grouping. For that group, we will define one number. Can be any number, example 1. And modes. For PAGP modes, one end is desirable, other end auto. If it is LACP protocol, then modes one end is active, other end is a passive. Like this, we can configure. Got it? See, between two switches, I'm connecting 3 links. 1, 2, 3 links. But by default, spanning tree protocol is enabled. What spanning tree protocol will do? It will start elections. Finally, it allows only one link. It will walk 2 links to stop the loops. Let us see the selection process first. Okay. See, it blocks two links, right? It allows only first link. Remaining two links are blocked. Means we can use only 100 Mbps link actually. Agree? So to combine 3 links and make it as a 1 link, we need to configure what? Ether channel. Let us configure Ether channel now. Before Ether channel, if we check show spanning tree, port number 3, port number 2 are block ports. So how many links are in first page? Currently, how many links are there, guys?
Total 3 links.
What are the port numbers is showing?
1, 2, 3.
1 to 3 ports, 3 links, right? Yeah. So out of 3 links, 2 ports are blocked. It allows only 1 link, first link. Means 100 Mbps only is forwarding the traffic. But my requirement is I want to utilize full bandwidth and for load balancing. Then we can combine the 3 links actually. Interface, range, fast Ethernet, 0/123. Channel protocol, first enable protocol. So you're using Cisco PAGP. Channel group number. We are grouping 3 links, right? Group number, any number you can use. My example 3 because I connected 3 links. Group number 3. Mode. PAGP modes are desirable. One and I have configured desirable. See, we got one notification. What is that? Creating a logical link. Port channel means logical, virtual, like one logical link. It's combining one. It's creating. It is not created. It is just creating. When it will create, other side, switch B also same protocol is enabled and same group number configured, then it will create a logical link and then that will be active. Just now it is processing is started actually. It is configured in other end also. Config mode. Interface range. Pass Ethernet 0/123. Channel protocol. PAGP. Channel group number 3. Mode. Auto mode. See. Interface port channel is up and protocol is also up. Even here also port channel is up. And let us wait for a few seconds. Now all 3 links will come to forward state, means green color. Okay. Yeah, I can see 3 links, green, here green. So now data communication go via 3 links. So before configuring of Ether channel, when you check show spanning tree, showing block port, 2 block port number 2, port number 3 block port, and port number 1 is forward. Means how many interfaces before Ether channel? There are 3
The
interfaces, fixed
interface.
interfaces. Now if you same command, if you check show spanning tree, how many interfaces?
One.
Only one.
Only one, which is logical interface. You're showing port channel number 3, the group number we defined, port channel 3, which is in forwarding state. Got it?
Yes, but what about these the waiting times? We still have to wait these 20 seconds, 15 seconds, 15
Yes,
seconds, right?
yes. So that is for STP protocol. There are advanced STP protocols are there actually, like RSTP, PVSTP, MST, many protocols. So if enable that protocols, that conversation will be faster.
Okay.
Yeah. Done. So successfully we have completed LAN technologies. Like have started introduction to LAN technologies and IEEE standards for Ethernet, fast Ethernet and all, and introduction to switch and switch functionality, switch types, switch categories, and then we started discussing about VLAN, VLAN concept, why VLAN, and how to create and how to implement VLAN, and trunking mechanism, dynamic trunking mechanism, VLAN, like VLAN trunking protocol, and inter VLAN routing, how to forward the traffic from one VLAN to another VLAN in 3 ways. Discovery protocol, CDP, LLDP, spanning tree protocol, hold fast mechanism, and Ether channel, switch level load balancing. Any doubts in this list? All right. See some network services today. Actually, how to start Cisco security classes before getting to Cisco security. We'll try to complete some network services. Just few, 3 services we have. We'll try to complete today, and tomorrow we'll start with Cisco security classes, like how to protect our network.
Balu, how many weeks left right now?
Sorry, your voice is not clear, man. How many?
How many weeks class left right
Oh.
now?
The last session will be on 29th, Thursday, next Thursday. It's almost less than 1 week.
Okay, thank you.
Yeah.
Before that, will we get some kind of material and for the test preparation and all those kind of stuff? Any documentation wise? Are you going to send any kind of information for us?
I shared some material, right? Like web links.
Okay.
For this presentation, course presentation and lab manual have shared.
Uh-huh.
From some PDFs I'm preparing, I'm downloading that. So I'll share it. This is only for not for exam. It is only for some knowledge purpose.
So where can we schedule the exam? Is it Zoom is
So finally, we have completed LAN technologies. Well, back to some network services. With a regular topology, I think everyone remember router concepts with R1, R2, R3. 3 routers topology. R1 connected to R2, R2 connected to R3 with serial 0/1, serial 0/0. Same, they are connected like this. So my point is, let me take R2 console. Yeah, I mean R2 console, right? After some time, there was some problem in WAN link. It is failed. Due to any reasons, it down actually. When it downs, the router will generate one log message. What is that? Interface serial 0/1 change state to down. Protocol is also down. Your link is up back. So when your link is up, again, router will generate the next one more log message, which is same 0/1 change state to up. Protocol is also up. Now 0/0 is down. Notification log message 0/0 is down. 0/0 is up. Again, generate log message. Please 0/0 is changed state to up, and protocol on 0/0 is also up. So if any link failures, routers used to generate log messages. In R1, in R2, I configured OSPF. In R1 also I configured OSPF protocol. In R3 also I configured OSPF protocol. Once you configure OSPF, they'll exchange hello packets. Once they exchange hello packets, and neighbor will establish. So when OSPF neighbor established, now router will generate one log message. So and so my neighbor is up. So and so my neighbor is up. 2 log messages. One is R1 neighbor, R3 neighbor is up. If any parameter is changed, like R1 is area 0, R2 is area 10. Initially it was in same area, later they changed into area 10 R1. Now area mismatch. They'll form the neighbor now? No. Then you can get one log message is neighbor is down. So what I'm trying to explain here, if any changes happens in the topology, generally routers will generate what? Log messages. These all the logs will be stored inside the router. A separate memory for that. We call it is buffer memory, buffer storage. This buffer is only for to store logs. All system logs we can get in buffer storage actually. System means router logs. Following me guys, everyone?
Yes.
Let's say day 1 logs, day 2 logs, day 3 logs, all. Basically, routers will maintain very low memories, like even RAM or NVRAM or buffer storage is very low actually. After few days, example 10 days, not exactly, just for example, after 10 days, what if your buffer is full? Your buffer is memory is full, no space in buffer storage. So what about for day 11 logs? But till
Probably
day 10, overwrite, yes. So router automatically it will erase earlier locks. So day 1 locks are erased permanently and day 11 will be replaced. For day 12, day 2 locks are erased permanently. Like is overriding. Earlier locks has been deleted automatically. It's been 1 year. There is one network audit. In network audit, there is one customer raised a request. They need a first 10 days logs. They're asking for first 10 days logs. They need to be checked why the time link is failed or what was the reason and when link is up. There is some business continuity lost actually. Then customer requested for I need a first 10 days logs. That logs are very important to case a file something. Agree? So can we provide first 10 days log for customer now?
no,
No,
it's already gone.
it's erased. It has been 1 year. Earlier logs are already deleted permanently actually. Then how I can provide logs to the customer now?
For every 10 days, we have to like store them separately?
Oh, okay. So this is one case actually. This is first case. In second case, network team, network engineers team, there are different job roles. N L1, network L1 engineers, network L2, network L3. This is basic level, junior engineers like that actually. 3 levels. These all are engineers, network engineers. Job role is network engineers. And there is one another team separate for initially for first time. NOC team we called it. Operation centers, network operation centers team. So what is the job role of NOC team? NOC team is for they monitor the customer's traffic 24/7. This is monitoring team actually. But this NOC team don't have privileges, don't have a credentials, don't have access for login to router, login to switches. Only engineers have access. They have a credentials to log into router and do changes actually. Then how NOC team will can come to know what are the logs are generating this router? Is all the logs will inside the buffer memory, means inside the router. So NOC team have log into router and check the logs? No. So two cases. First case buffer will be full and earlier logs will be erased, deleted automatically. The problem. And second case, NOC team, how they can monitor what happening inside the router actually. I'm sitting at my home and I want to monitor like in customer routers. So one of customer in Delhi, one of customer in US, like I need to monitor those routers, what happening inside that actually. And how? So to overcome these both issues, instead of storing these logs inside the router, we'll maintain one external server. Will will maintain one external dedicatedly for logs only with 10 TB, 20 TB disk space. So this server we called syslog server for logs information. Then you configure to router 2, telling that router 2, if you have any notification, you don't store in your route inside your memory, you immediately send to server. That we need to configure. Configure in router 1, configure in router 3, configure in all networking devices, configure any log messages sent to syslog. If link fail, syslog will get one notification message. OSPF neighbor up will get one notification log message here. So what are the happening inside the router? Every notification will get in syslog, and it will store permanently for years and years. Once audit is completed, then we can arise with some rules. Okay, at least we can maintain 2-3 years. Automatically logs will come. We no need to be take backup for every 10 days or 20 days or 1 month. No need. What happening in R2, R3, or all routers, traffic will, I mean, logs will come to syslog server. What this NOC team will do, how they can monitor. So NOC engineers, they'll connect to syslog server. From remotely, from anywhere, they log into syslog and open the screen. Continuously, they can see logs. What happening in R3, what happening in R2, what happening in R1, all the log messages they can monitor. If any one critical log, so they know the logs actually, notification 1, notification 2, these different levels. Notification 3, I mean level 3 log, it is resolved by L3 team or L2 team or L1 team. So based upon the logs notifications, this NOC team will assign the tickets to respective teams. Your network engineers will be available online in office hours. NOC team will continuously 24/7 monitor the shift wise. So there is one ticket, there is one issue on router 2, which is need to be changed, I mean reconfigure. NOC team don't have a privilege to configure change. So what NOC team will do, they will initiate the ticket to engineer, so and so router, so and so configuration need to be done. Then engineer will be log into router 2 and they will change the configuration, and NOC team will see that issue is got solved. And there is a critical issue like that can be solved by L3. So NOC team will send ticket to L3 team. L3 will be taking action. So this is how exactly happening in the corporate network engineers, the job roles actually. It's clear? Syslog is a protocol that allows a network device to send their system messages across the network message collectors. The syslog is typically used for network management and security auditing purpose. So device can be configured to forward syslog messages to various destinations. One is buffer, which is internal memory buffer. Another one is syslog. So best practice is syslog. Even we can do practical in packet tracer also syslog. Have one server is there. I'll show you the practical in just a minute. Server connected to network. First thing, let me assign one IP address to server. 10.0.0.123. So what is server IP address? 10.0.0.123. Go to services option. There are many services. One of services is syslog. Currently, we don't have any logs here right now, right? But syslog is on because we need to configure in router. Excuse me. Logging on. Logs are on. Logging host. What is server IP? 10.0.0.123. So what I'm telling to router 2, your notifications are on. If you have any notification, you please send to this server, which is 10.0.0.123 host. Done. Now let us do some changes actually. Syslog. Link removed, link up, link removed, link up, removed, up, removed, up. Some modification system. Now if you see logs generating, getting the logs continuously. Clear? Is all the logs is coming from zone 10.1 router actually. Okay. Any doubts about this log? Okay. Next service is, see, I'm in router 1 right now. In router 1, show clock. If you see the clock on router 1, R1, enter. Showing the clock. Router 1 clock is 1993 1st March. 1st March 1993 showing us. R1 1993. Let's say R2 is in 2022. Now if we configured OSPF on both, R1 will send hello packet to R2. On what date? In 1993. R2 is in 2022. So then R2 understand, so I'm receiving hello packet in from 1993. So R2 cannot be trusted because OSPF protocol hello timers every 10 seconds they exchange. Hello timers, dead timers should be matched. So they cannot be trust actually. I'm in 2022, but you are in 1993. How can trust you? No, can't trust you. I'm not from a neighbor. So very important point is in an entire domain, every network devices should be maintained exact date and time. Then only proper communication and proper protocols, because this is algorithms, right? Protocols are working. Every millisecond is also important actually. Have a routers, switches, firewalls, access point, every devices and servers, computers, every devices should maintain exact date and time actually. To maintain exact date and time, we have an option called automatic set date and time. Correct? Are you using manual clock setting for your computers or you're using automatically? What do you guys? What option you're using?
Automatic.
It's automatic.
Why? Why not static manually?
Because if it is manual, then one person will set one time and another person will set another time.
No communication. There will be time difference. You do one small practical on your laptop. You just change your date and time and try to connect internet. Is it possible? No. Because internet, if you want to change, if you change your date and time in your laptop and you connect it to your first device, what is that first device? Your Wi-Fi router. Agree? Your Wi-Fi router date and time is different. Your device is different. No synchronization, no authentication. They will not accept you actually. Even if it's connected, no internet, because internet servers are not. You remove automatic date and time. So every device should maintain exact date and time. Even for router also. I'll show you the two options. One is manually can set clock, but it's not a best practice. Automatically should get date and time actually. How to set the manual clock? In privileged mode, you can use this command: clock set 09:. 11 colon 10. Hours, minutes, seconds. Space. 23rd September 2022. Hours, minutes, seconds, date, month, year. Show clock. So it's Friday. Like you can set. But if you are doing them manually for each device, difference will be there now. So this is not a best practice. Then what we'll do, we'll maintain one more server in our organization dedicatedly for time synchronization purpose. Already we have one server. This is server dedicatedly installed for what purpose? To collect logs, notification logs messages. And we'll maintain one more dedicated server for time synchronization, which we call NTP, Network Time Protocol. Router 2 will sync up with the server. Router 1 will sync up with the server. Router 3, like your all devices, all networking devices will get automatically corrected date and time from one centralized source zone, which is NTP server. So we need to enable NTP in all routers, all devices. If you enable NTP, then it will get from here, automatically sync up. That is network time protocol. Network time protocol, NTP. Manually setting the clock of networking device is not a best practice, actually, not scalable. Best practice is NTP server. NTP is used to synchronize the time throughout the network devices like a server, switches, routers, access points with a centralized source clock. Okay, I'll show you one practical how to sync with NTP server. Same, this server only. Services, you can see NTP option we have. NTP is already on. Just if enable one command, which is NTP server. What is server IP? 10.0.0.1.20.
10.0.0.
Yes, done. Now if we check router 2, show clock, Friday. Good, exactly, date and time. Okay. What is showing the clock? Even for router 2, clock is showing is what? 1st March 1993. Okay. That's connected server to network. Still, it's 1993. NTP server 10.0.0.1.23. Now if you check after enabling this command, now if you check clock, show clock, still the ports are not active. Yeah, this now it is active. Now if we check, it's not still synchronized. Ten zero zero 123. Let us enable one more time. NTP server 10.0.0.123. Show clock. So I have just rebooted, right? I'll do one thing. We'll see this practically in R3. For R3, server IP is 192.168.2.123. So before enabling NTP, first let us check this clock on R3. Show clock. Even showing 1993. R3. Now if enable NTP server 192.168.2.123. Show clock. So Friday, September 23rd, got automatically. It is synchronized. Before enabling this NTP server command, it's showing 93. Just to enable this command. So router 3 is got a automated date and time from server. Like this, all networking devices synchronize this clock with centralized host clock. Centralized host clock is NTP server. All servers, all devices, it can be any switches, servers, routers, access points, every devices will sync with the centralized host clock using NTP protocol. Clear?
Yes, clear.
Right. The next point is router 2 connected to LAN. So this is fast Ethernet port, IP address 10.0.0.1/8. In the LAN, some devices are connected. Device 1, device 2, device 3, device 4. Number of devices are connected. Basically, who will use these devices? Network engineers are we use? No. Why we require computers? We don't need now. We are providing a network setup, that's all. Ultimately, this is engineering team will be used. Like a software engineers or whatever the production is going on in your company, that team will be used for computers. Agree? Like a sales department, HR department, IT department, different departments. But point is, every device must require IP address, subnet mask, default gateway, DNS server IP, DNS IP. Every device's parameters are mandatory. Then only this device can get internet or can part of a network. So how this engineering team will come to know, oh, router is in 10. Network, it is in /8. So we have to use the same IP address. So one of the engineer used 10.0.0.2. And how another engineer knows about 10.2 is already used. It will be complex now. So instead of manually, statically IP address, we enable DHCP. Actually, to provide automatically IP address for all end devices, we'll maintain one more separate server. For what purpose? To assign automatic IP address, which is what? DHCP server. So one company, one organization will maintain many servers. One server for syslog, logs information, one server for time synchronization, one server for IP alertment, and one IP for DNS, one server for storage, like different servers. To manage these servers, again, there is a separate team. Because in this server, they may install Windows or they may install Linux. So that system engineer will manage. The engineer who knows well about Windows operating system or Linux operating system, that team will manage this servers action. Okay. But in our case, we can configure DHCP on router also. So router can provide automatic IP address on for clients. So how to enable DHCP on routers? Once you've enabled DHCP, then DHCP means router will provide automatically IP address, subnet mask, default gateway, DNS IP for all client machines. Got it? Anyone can tell me just process how you are connecting to internet from your mobile phone or laptop. In your day-to-day life, how you are connecting? What is the process?
OSI layers?
No. My question is from your mobile phone, how you are connecting to internet? Simple.
Wi-Fi?
Tell me the process. What do you do?
Turn the Wi-Fi on. You search for the network.
And search for the network,
Indicate like giving the password when you connect,
password, connect.
and then open browser and test it.
That's all, right?
Yeah.
Are you assigning IP address to your mobile phone?
No.
Assigning subnet mask, default gateway? No. Even the same process for laptop also, right? You just
Yep.
click on network adapters or Wi-Fi adapters and just connect it. It'll ask authentication and just you enter password. That's all. We are not assigning IP address to your laptop. You're not assigning IP address to your mobile phone, but every device must require IP address, subnet mask, default gateway, and DNS. But we are not assigning. Then how we are getting? We're getting from DHCP.
Yep.
Yeah. So that DHCP is configured in router, your Wi-Fi router. It's pre-configured in your Wi-Fi router because you're connecting to Wi-Fi router, right? So once your authentication is done, then your Wi-Fi router will provide automatically will allocate one IP address to your device. So dynamic host control protocol is used for dynamic IP address assessment to networking devices. So what DHCP can provide? IP address, subnet mask, default gateway, and DNS server IP address to DHCP clients. So router can be configured both as DHCP server and DHCP client. Means router can generate the IP address and can be received also. This is the configuration part. I'll show you here. Let me remove this server. Adding 3 more devices. So let us enable DHCP on R2. Config mode, IP DHCP pool. So we are creating one pool, a network. For that pool, you define some name. Can be any name. My example, CCNA. IP DHCP pool name on which network. Network is 10.net network. And what subnet it is? It is 255.0.0.0. And default gateway. Default hyphen router 10.0.0.1. DNS. If you have any local DNS, you can assign, or you can use a global DNS. DNS hyphen server global DNS 8.8.8. Done. That's all. Now, just click on PC. Naresh. Yeah. Go to desktop, IP configuration. If you request from DHCP, requesting IP address, DHCP request successful. See 10.2, you got 10.2 IP address, subnet mask, default gateway, and DNS server IP. Close it. From desktop to request for DHCP, requesting IP address, request successful, got 10.3. Like every machines will get automatically IP address. So what is the first machine IP address? First machine IP address is 10.2. So first machine IP address got 10.2 IP address and by 9:30 a.m. and 23rd September. So this 10.2 IP address will be the same for the device how long? So first device got 10.2 by 9:30 a.m. So 10.2 IP address will be the same for that computer how long? For 1 hour or 2 hours? Or permanently same computer will get same IP address? What?
It's not permanent. It will change.
Okay. When?
Like
Then
when
I'll ask you one question. By 9:30 I got 10.2, right? By
Mhm.
9:45 my PC is rebooted. I have restarted my computer. So will I get the same IP or will be change?
It will change. You'll get a new IP.
No, it will not change actually. Even immediately if you reboot or after some time if you reboot also, IP will not change. So there is certain time actually, the time we called DHCP lease time. So that lease time we can set. If we don't set, there are default lease timer, depends upon the device, depends upon DHCP server. We can configure DHCP server on Windows, we can configure DHCP on Linux, we can configure DHCP on Cisco router or a home router. It depends upon which device you are using actually. If it is a Windows server, default lease time is 8 days. So you got 10.2 IP address from DHCP, which is Windows DHCP. Then if you do shutdown on multiple times, if you reboot, you'll get same IP address 10.2. By 9:30 or 10:30, if you shut down it, and your PC shut down up to 6 hours, over the night it is in shutdown state, then you may IP will be changed. But in between, if you have multiple times, if you reboot also, the same IP address will be there. Okay.
What if we change the ports?
Port means
The cable, the internet cable ports.
yeah, it might be changed. If we change to another port, request will regenerate. It will be changed.
Yes. Okay.
But if we change the port also, if we need the same IP address, then we need to bind MAC. This computer MAC address is A2, and this spaces should get always 10.2. You bind with this MAC A2. Now you can change the ports anywhere. Anywhere if you connect any port, if you connect in the network, the same A2 machine will get 10.2 only. That option we have actually. Depends upon the lease time. The lease time we can configure. If it's Cisco DHCP, 24 hours is the lease time actually. Default lease time is 24 hours. However, you can change. Like we can change 10 to 5. Means days, minutes. Okay. No, sorry. Dates, hours. Days, hours and minutes. So 10 to 5 means 10 days, 2 hours, 5 minutes is the lease time. After 10 days, 2 hours, 5 minutes, the IP might be renewed. So number of days we can configure, number of hours also, or number of minutes also. Or you configure like this, 0, you configure like this, 0 space, 25 means the lease time is just 25 minutes only. 0 days, 0 hours, 25 minutes. Like we can count. Anyone, can you do one thing? You just open your command prompt and tell me your IP address, your PC, your laptop IP address. Quickly.
One nine two 192.168.1.93.
1.93. So when this IP address is obtained for your device, and how long this 1.93 will remain for your computer? How we can get that information?
If you find out the lease time.
Yeah, you do one thing. You use to check IP address, use ipconfig command, right?
Yep.
You can use ipconfig/all command.
No, it's a Mac. I used it just by selecting network adapter.
Okay. See, if you see this ipconfig/all in Windows, then lease
Okay.
obtained when? Friday for my laptop.
Mm.
23rd September, when?
So
7:56, just before of your class I started actually, my laptop turned on. Lease expires when? Same
24
24th
hours.
September. 24 hours is the lease time actually. Like we can check. Next point is, so DHCP started assigning IP address for all devices in 10.2, 10.3, 10.4, 10.5, 10.6 like this. But my requirement is I need a separate, I need a sub range of IP addresses we need to use for statically in my network. Then we can write some condition to router DHCP. You don't use 10.2 to 10.30 IP address. This range you don't use. I will use this IP addresses for statically. This condition you can write to DHCP. Then DHCP will never use this range. DHCP will start from which IP address? 10.31. So how to exclude that range is, you can use this command. IP DHCP exclude address range, start IP 10.0.0 to space end IP 10.0.0.30. Done, that's all. Pool we created entire 10.10.0.0 whole network. From that network, these IPs are excluded actually. Now if you test again, for first computer, you just re-request for the DHCP, requesting IP address. So I got 10.31. The DHCP request successful, 10.31. 32, 33. So DHCP will never use 10.2 to 30 because it is excluded actually. Then this range, excluded range IP address, we can use for statically from specific servers, any devices. Got it? And which IP address assigned to which device in your network. To check that, you can use this command: show IP, DHCP, binding. So and so device 10.3 is assigned. So and device 10.31 is assigned. Like, you can see the binding list. Clear, everyone? Yeah. So syslog, NTP, DHCP, these all are network services. And tomorrow we'll continue with Cisco security sessions. Thank you. Have a good day. And please ping me about regarding that